Good evening. Am I audible? Can you please reply? Can you please reply whether I am audible or not? I'll be just waiting for a few minutes so that other students can join. Yes, am I audible? Yes, because you have joined so good. I am fine. So am I audible? Because okay, just wait for some minute. Okay, 1 or 2 minutes. Just I am going to start. So as you know that in this video we are going to discuss definite integrals, and this is for JEE Main and JEE Advanced topic. I hope it will be useful for your preparation, those who will be appearing for JEE. Okay, so let me start now. So if you have any doubt, the time you will let me know. So this is the definite integral. Here we will be discussing these few problems. So here there are 11 problems, and then we will be discussing more. And here you will see that some absolute functions are given, some greatest integer function. So this kind of problem I have collected. And next, so these problems as well as this one, okay, these are all total problems we will be discussing. Okay, I think my screen is visible, you can hear me also. Okay, so before going to start solving these problems, let me discuss little bit about this definite integral that all of you know. Some brief introduction about this one. So you know that definite integral here, just 1 minute. So this integration a to b f of x dx okay. So my screen is visible to all of you. I think it is fine. So this we can compute if suppose integration of f of x dx, if it is capital F of x plus some constant c, this is indefinite integral. In that case, if I put this limit, lower limit, upper limit, we will get this f of x is the integration and it is your c. There if I put this lower limit and upper limit, you will get simply f of v plus c minus f of a minus c. So see, this c will cancel out. So simply you will get f of v minus f of a. That you know. Now what is the meaning of this integration? Integration, suppose if I have one function, this one, and this is your x-axis, this function f of x, and if this is the point a, x equal to a, this is the point x equal to b, okay. Now this integral is nothing but to compute the area under this curve within this range a to b. So this area is simply a to b f of x dx, okay. It's very simple thing. Now as this is the area, now we can extend this thing with certain one simple idea. I can take one more point. Suppose this point is C, then I can take first this area, then I can choose next area. So total area will be again from A to B. Then why not we can write this A to B f of x dx the same as, I can first consider A to C, then I can consider C to B, okay. This is your f of x dx, this is again f of x dx, okay. I think it is clear. So we can introduce some point, again we can have more divisions, okay. Those divisions we can include. Now we have certain objective to include more divisions. So if function is continuous, perfectly one function, then there is no need to take more point within that interval. However, if function is defined piecewisely, like if I consider one function like this, suppose this is the function and we want to, this is the x, this is your f of x, and this is your a, this is your b, and so this one is c. So if function is like this, so obviously you can't integrate from a to b directly, because function is defined from a to c and then again c to b. So it is better to compute this area first, then we can compute this area later. Okay, so this function a to b, f of x dx, that one we can compute easily if I consider 0 to, so it is a to c, f of x dx, right, plus this one is c to b, f of x dx. Clear? So if function is defined piecewisely, then it is useful. So that kind of function we will get normally. So here I will discuss two functions. One function is called absolute function, and second one is called greatest integer function. Right? So these two functions we need to understand, and lots of problems are coming from these two areas only. Right? Only this absolute function and greatest integer function, lots of problems are coming. We will be discussing some interesting problem based on these two. So let me define these two, okay, then you will get certain idea about this one. Just 1 minute. Okay. Now we will define absolute function. Now it's very easy to define. So this mod x or absolute of x is equals to x for x more than 0, or equals to, I can put equal sign as well, and this is equals to minus x for x less than 0. What is the meaning? Graphically we can understand better. Right side is the positive axis, is 45 degree, y equal to x, this is your x, this is your mod x. So positive side is again same, y equal to x, but left hand side it is again positive side, this one, y equal to minus x, this is again 45 degree. It's implied that if I consider, for example, mod of 2 equals to 2 and mod of minus 2, again it will remain 2. So it does not depend on the sign, it's positive or negative, its value will be only the positive. Okay. So this is your mod x. Now can you draw, suppose if I want to draw mod of x minus 1. So what will do? So when it will be 0, so vertex I need to find out. So at x equals to 1 it will be 0. So first I will put these things, x equals to 1 here. There I will consider this mod x. So its meaning is that this mod x is shifted right side by 1 unit. Okay. Very easily we can draw this mod of x minus 1 or x minus alpha. Okay. So these things are very easy things. So this is one thing, absolute function. Another function is the greatest integer function. Okay. Now in getters integer function, this is defined. So this is the notation used, and this is the getters integer value of x. Okay. So if this is equals to n for x, if it is less than equal to n, so n less than equal to x and less than n plus 1, n is integer. Okay. Now what is the meaning? The meaning is that, so if I take one example, so it is getters integer value of 1.2. So I can write 1.2 is within 1 to 2. Okay. So in first integer it will start from 1. So its value is, this integer value only it is 1. Similarly, getters integer value of 2.9, it will be 2 only, this integer value. Okay. But be careful about negative side, minus 0.5 suppose. Okay. This value is minus 1, not 0. But 0.5 only positive value, that is equals to 0. Okay. Now if I draw this its curve, then you will understand better. So this is your x, this is a getters integer of x. So you can see that it's 0 to 1, any point if I choose, so its integer value is 0, so its value will be 0 only. Okay. And 1 to 2, its value will be 1. 1 to 3, 2 to 3, its value will be 2. Okay. This is 1 and this is 2, like that. So this is stepwise, it is increasing. Then it will be 4, like that. And left hand side, it is minus 1. So minus 1 to 0, its integer is minus 1. Okay, like this. Then minus 1, minus 2 to minus 1, its value will be, this is minus 1, its value will be minus 2, like that. Okay, so be careful about negative side. So suppose if I consider, again I will consider minus 3.5. Okay, so what you can write? This minus 3.5, I can write it is within this minus 4 and up to 3, within this range. So this, it will start from minus 4, thus its value will be minus 4. It's not minus 3. Be careful here. Okay. Now we'll start our discussion. We'll solve the problems from the absolute functions and getters integer function in integration. Let us consider this thing. So you will work in the both way, graphically as well as with calculations. So first problem is this one. So how to solve this problem? So you know that mod x will be more than, is always positive. Okay. So already I have said that this mod x is equal to x for x more than 0, and this is your minus x for x less than 0, or I can put equal sign somewhere. Okay. So what I can do, this one I can break. I can consider minus 2 to 0 one region, another region I can choose 0 to 2. So within this minus 2 to 0, that time, so this will work, x is negative, so I should put mod x by its value minus x dx, and within this 0 to 2, the mod x is replaced by simply x into dx. Okay. So now we can integrate easily. So this integration will be very simple, minus x square by 2, and it is minus 2 to 0. This is your x square by 2, 0 to 2. So if you put the limit, so first this minus half I will take outside. So x equal to 0 is 0, and this is for minus 2, it is 4, so it is minus 4, and this one is plus, this is half outside, this is 4 minus 0. So this is becoming, this is 4 by 2, this is 4 by 2, total is 4. So I can solve this problem graphically very quickly. So how to solve this problem graphically? Okay. So what I'll do, I'll draw this graph. This is your x, this is your mod x. Okay. So what is the plot? This is the mod x. Right. So minus 2 to plus 2. So you need to consider it is minus 2, 2 plus 2. Within this, I need to find out the area. So this area plus this area. So what is the area of left side? So this width is 2, this height is also 2. Okay. So what is the area? Half into base into height. This is triangle. So this triangle I am considering. Okay. So half into base into height. Similarly right side, it's symmetrical. Again half into base into height. So okay. So first one is 4 by 2. Second one is also 4 by 2. So total is 4. So very quickly without any integration we can solve it. Now is it convincing? Can you reply please? Because are you there? Okay. Okay, let us move further. The next one. So can I solve this problem? So now, as you know the graphical one, so graphical is the best methods, easy methods. So why not we will go for graphical only? Okay. So I will draw this function. So this is your x, and here I need to draw x minus 5. Okay. So what to draw? So this vertex will be x equals to 5. So at x equal to 5, this is the vertex. So there, this one and this one. Okay. Now you can see it is 2 to 8. This could be 2 and this could be 8. Okay. So this area we need to find out, this and this. Again, this width is 3. So this height will be also 3. This width is 3. This height is also 3. Again same thing. So it will be half into 3 into 3 left hand side area. Again it is same thing. So I can multiply by 2. Okay. So 2 will cancel out. So 3 into 3 is 9. So its value is 9. Okay. So it's very easy to compute this kind of problems. Okay. So let us move further. Now this problem came in 1989 JEE. So can you solve this problem? Okay. Can you solve this one problem? So this is a little bit tricky. It is mod of 1 minus x square So how to handle this kind of things? So this is not a linear thing, it is non-linear. X squared term is given, so how to find it? Easy way. So mod of 1 minus x squared, that I can write mod of two factors, 1 minus x and 1 plus x. Okay, so you should use some sign convention, then you can handle in a better way. Okay, so what is this? So this here, this is the x axis. Now these 2 points, when x equals to 1 here and x equals to minus 1 here. So these solutions, so its solution is x equal to 1, that time it will be 0, and its value it will be 0 with x equals to minus 1. Right? Now this function, the function 1 minus x square means 1 minus x times 1 plus x. This function will be positive. This is positive for this side when x is more than 1. Okay, then this region, then next one is this one. This is minus 1. Okay, remember. And this is your negative alternative. This is positive, this is negative, and this is again positive. So just I will find the corner points, okay, when it will function will become 0. So the right side points is always positive, because right side this is positive. If this is positive, if x is more than, so one thing, I think it is 1 minus x is given. Okay, it should be negative. Okay, and it should be positive, and it should be negative. Am I correct? Little bit corrections, because it is 1 minus x is given, not x minus 1. So whenever x is more than 1, it is negative, or if it is less than minus 1, it is also negative. Okay, so these are 2 situations, and so I can write that 1 minus x square, that one, its absolute value will be same as 1 minus x square for x within 1 and minus 1. Okay, and this will be negative of 1 minus x square for mod x if mod x is more than 1. Right? If mod x is less than 1, then means x is within plus 1 and minus 1, it will be positive only. So it is 1 minus x square, and outside this one it is negative. Right? So how to solve this problem? So what to do? So now just 1 minute. So we have got this one. So now we will have this is equals to, I will consider on range minus 2 to minus 1, then minus 1 to plus 1, and third one will be, this will be simply plus 1 to plus 2. Okay, these 3 things we will consider, and within this minus 1, minus 2 to minus 1, that time it is negative, so only minus 1 to plus 1 it is positive, so it will remain same, 1 minus x square into dx, and this time it will be minus times 1 minus x square into dx. This is also minus 1 minus x square into dx. Okay, is it fine? So can you now solve this? I think it is now very easy to solve it. So you can see that this one, it's minus sign outside, then its integration is x minus x square by 2, it is minus 2 to minus 1, and this one is plus sign, again x minus x square, sorry, it is x cube by 3, okay, x cube by 3, and its value will be minus 1 to plus 1. This is again minus sign, x minus x cube by 3, it is 1 to 3. Now you need to simplify it and you will get the answer. Okay, I hope you can do that one. That is not difficult now. Just put the values, all those things, and its answer you will get. If you put everything, I think you will get 4. Yes, so answer is 4 we are getting. That's simple. Okay, so this is the idea. Main idea is that you need to break into linear regions, one regions where it will be positive or negative. That you should make confirm, and then you can do these things. Very simple. Now we'll move to the next problem. Now can you solve this problem? The mod of cos x dx. Okay. So we'll understand graphically what is the cos x and mod of cos x. Then the integration thing will compute. Okay. So here one thing, this function's cos x is a periodic function. Okay. So what is the waveform? Can you draw the function? If this is x, so cos x, it will start from 1 with x equals to 0. It's like this. Okay, this is your plus 1 and minus 1, right? And you can understand that this value at cos pi, it is minus 1. This is your pi by 2, and this is again it is 2 pi. Okay, this one is minus pi and this one is minus 2 pi. Okay, now if I take mod, so this is your cos x. Now if I take mod, then the graph will be a little bit different. So negative part will become positive. So mod of cos x, I want to draw mod of cos x. So this part is positive and this negative will become positive. This positive will remain positive and this is positive, fine, but this one is again becoming positive. So it will be like this. So this is your pi, this is 0 and this is 2 pi. So mod of cos x, it is periodic function and periodicity is pi. Okay, so period of mod cos x is simply pi. Okay, because every pi it will repeat the same thing. So now this periodicity we will use, we will consider. So how to handle this kind of problems? Now here I want to discuss something. Okay, so just look at this one. What I will do, let me 1 minute please. This part I will remove it. Now one thing is that, so this anything function is periodic, f of x dx, right? So if I consider one function, its value is 0 to capital T, T is the period, then it will have certain value. Now if this value is capital I, now if I repeat these things again, we understand that f of x plus capital T or minus T, that is same as f of x. Its period is capital T. Okay. So in that case, what I can consider, if I have 0 to suppose 10t f of x dx, okay, that we can break in this way: 0 to capital T plus capital T to 2t, then 2t to 3t, like that, and 9t to 10t. This is your f of x dx. Okay. Now every integral, as it is periodic, the area under within one period will remain same. So this will be I, this will be again I. So I am not writing here. Okay. This is f of x dx, this is f of dx. Okay, like that. So this is all are I. So it will be 10 times of I. Okay. So this is one important thing. So in general, if I consider 0 to nt f of x dx, that we can write n times 0 to capital T f of x dx. Okay, this is for periodic function. Right? Now, how to get these things, total things? Okay, so for this one, what I will do, this minus 2 pi to 20 pi to plus 20 pi, this function I need to find out. So here, for this one, so I will remove these things. Again, one more thing is that, so it was 2 for 20 pi, right? Now one more important thing is, if I consider minus or mt to nt f of x dx, okay, that we can write as n minus m times 0 to t f of x dx. Okay, and that is very easy to prove. How to prove these things? So okay, this thing I can write as mt to 0 f of x dx and plus 0 to nt f of x dx. Clear? So this one, this limit we can interchange. I can put minus sign, 0 to mt f of x dx. Okay, and this I will remain as it is, 0 to nt f of x dx. Already I have said that this will be equals to, so this value will be m times of this I, okay, and this will be n times of that I, so it will be n minus m times of I, where I is simply, this is your I, 0 to capital T. Okay, so I think it is very easy things. So this kind of problems easily we can solve it. So if we understand this concept, so from mt to nt, this fx dx, if fx is periodic with periodicity capital T, then we can write n minus m times 0 to t fx dx. Okay, so for this problem, what we will do? Now it is very easy. Okay, so this simple thing we can write as, so as it is 20, so 20 pi, and we can write 2 times because this is even function. I can write, so this is very easy things we can do. 2 into 0 to 20 pi, because it's both side is given, mod of cos x dx. Okay, first thing, that thing I can do, because minus 20 pi to 0 and 0 to 20 pi, it is same thing, so it is 2 times of that thing. Okay, now again this one I can write 2 into, so as mod cos x, it's a periodic function and its periodicity is pi. The pi is a period that we have shown it. Okay, so it is 20 times of pi, so that 20 I can take outside. It is 0 to pi mod of cos x dx, right? So this mod of cos x 0 to pi, now you can integrate and you can do these things. So it is 20 pi, it was there, no? 20 pi, 20 into, okay, so it is 40 times 0 to pi mod of cos x dx. So this one again I can do this thing. So what is the graph? This is the cos x over x, but if I consider mod 1, then this is and this one, like that. This is a mod cos x. Now this is your 0 to pi, so this area we need to compute. So you can easily see that 0 to pi by 2 and pi by 2 to pi, it is again symmetrical. It is very symmetrical. So 0 to pi by 2, what is the area? It is 2 times of that. So why not we can write, it is 80 times of 0 to pi by 2 cos x mod cos x dx. Okay, and within the 0 to pi by 2, cos is always positive, so we can remove the mod sign. So this is your 80, and so your integration is simply sin x, and it is 0 to pi by 2. Is it okay? So this sin pi by 2 is 1, thus, and sin 0 is 0, thus its value is 80. Yes, so 80 is the answer, is perfect. So now I want to give you some quick result. So this kind of problem, so this is the curve mod of cos x. So 0, it is pi by 2, this is pi, it is 3 pi by 2. Okay, so already you have seen that this area is 1. Okay, so this area is also 1. So or over one loop, this loop I can say its area is 2. Total is this half and half portion is 1, another half portion is 1, it is 2. Okay, so within 0 to pi by 2 it is 1, or 0 to pi it is this one. Okay, so these kind of loops you can understand how many loops are there. 0 to pi. So 0 to pi total area. So what I want to mean, 0 to pi mod cos x dx, its value is 2. Okay, very similarly, if I consider mod sin x dx, again 0 to pi, again it will remain 2, because sin x cos x shape will not change, it's periodic. Okay, so this is very useful. So mod of sin x, if I consider 0 to pi, then also I will get 2. Okay, mod cos x or sin x doesn't matter, so its value will remain 2. Okay, so in sin x you will see that this is the sine function 0 to pi. Okay, this is the mod sine. So this area is 1, sorry, it's 2. Okay, so we can use this kind of concept to solve it quickly, very quickly. So next, so can you solve this problem? So can you solve this one? This is mod of sin x plus mod of cos x, that's square terms incoming. Okay, and already I have said that mod of sin x and mod of cos x, these are two periodic functions and period is pi, right? So as both are periodic and it is a pi thing, so easily we can write that, we can simplify this thing as, this 20 is multiplied there, so 20 will be outside, 20 times I can write 0 to pi only, and this is mod of sin x plus mod of cos x. Okay, and this is square dx. So individually, some mod of sin x, its period is pi, mod of cos x, its period is also pi. But whenever you will consider the addition of these two, this, if I consider a function f of x is mod of sin x plus mod of cos x, this is my function and this is again periodic, and we can show that this is the periodic and its period is not only pi, it is pi by 2. Why? Because if I consider f of x plus pi by 2, what I will get? Mod of sine of pi by 2 plus x plus mod of cos of pi by 2 plus x. Okay, now you can see here that this mod of pi by 2 plus x, it's your sin x again, so this is again mod of sin x, and this one, sorry, it is a cos x. Okay, simply cos x, and cos pi by 2 plus x is your minus sin x, it's a minus sin x mod, but minus sin x mod and sin x is the same thing, so we can write that this is the same thing, I can consider positive as well, so I will get the same function f of x. That implies that this function f of x, sin x plus mod cos x, its value is, this is periodic with periodicity pi by 2. That is very important. Okay, so again we may consider this one. So what I can do, so directly we can go for these things instead of this one. So as this function is periodic. So this is periodic with periodicity pi by 2. So it's 20 pi. We can write 40 into pi by 2 directly. Okay. Thus, this I. So what is the I? This one is 40 times we can write 0 to pi by 2, then mod of sin x plus mod of cos x, that square dx. Now within this range 0 to pi by 2, both sin and cos are positive. So now I can remove this mod sign. Okay, so this is your 40, and within this 0 to pi by 2, this is your sin x simple, and this is your cos x, and that square dx. Now we can expand this one. This is 40, this is 0 to pi by 2. So if I consider sin square plus cos square, a square plus b square plus 2ab, 2 sin x cos x, right, and then dx. So this one, sin square plus cos square equal to 1, and this 2 into sin x cos x, that we can go for sin 2x. Okay, so it is 1 plus sin 2x. Okay, so now we can replace this thing as so this is equals to, this is 40, it was there, times 0 to pi by 2, first one is 1, second one is sin 2x dx. So now you can integrate easily 40, and this is your x integration, this is sin x integration is minus cos x, cos 2x by 2, and it is 0 to pi by 2. Okay, so can you tell me the answer? Okay, so this is your 40. So if I put pi by 2, it is pi by 2, and cos pi, so this is your equal to minus 1, so it is plus half, and for 0 it is minus 0, and minus 1 is a plus, this cos 0 is 1, it is again half. Okay, so half and half is 1, so okay, so this is 40 times pi by 2 plus 1, or we can write it is 20 times pi plus 2. Okay, is it correct? Am I correct these things? So have you got this answer? So this problem appeared in JEE exams. Okay, so this kind of problems you should be able to solve it. Okay, next problem we will tackle. So can you solve this problem? Anyone please? Just look at the problem, log x by x. So but it is given within this absolute one. Okay, now see the range, it is given lower limit is e to the power minus 1, upper limit is e square. Okay, and you know that log x, so it is always positive. E to the power minus 1 is also positive, e square is also positive, but log of, so x is no problem at all, x is positive, so only problem is this log x. So this log ax base e, this is positive if x is positive if x is more than 1. okay, and it is negative for x is within 0 to 1, okay. So that is the limit. So x equals to 1. So we need to break this thing in two ways. So this integration I should consider in two range, e to the power minus 1 to 1. Another one would be 1 to e square. This is the only two limit, okay, e to the power minus 1 to 1, and that time it is negative, so I should put minus log x by x dx, and here it is positive, same thing, I'll put it log x base e upon x dx. Now I think you can integrate this one, that is very easy. If you put log x equals to z, then its derivative will be dx, dz will be 1 upon x dx, okay. Thus you will get this integration of this one will be log of x square, because z dz means z square by 2, okay. So its value, this minus and minus is outside, it is a log x that square, okay, by 2. This is the integration. Limit is e to the power minus 1 to 1, okay. Next one, this one again, log x that square by 2, and limit is 1 to e square, okay. Can you compute these limits? So when log 1 is 0, and be careful here, log e to the power minus 1 is minus 1 and log e square is 2. That's simple. You replace these two things. Log e to the power minus 1 is minus 1 and log e square equals to 2 only, because 2 is count outside. Log e base e, that I think you understand. Log e square is 2 into log e base e, that is equals to 2, okay. Similarly, log e to the power minus 1 will be minus 1. You replace these two and you will get the answer, and total answer you can compute. Can you tell me what is the answer? Are you working on this problem? I hope you will get the answer 5 by 2, okay. So this is the way how to solve the problems. So this problem appeared in 2000. So this kind of problems may come in JEE exams. Be careful. Okay, next problem. Now we will go for greatest integer function. And greatest integer function already we have defined. Quickly we will revise again. What are the greatest integer functions? X with respect to x, 0 to 1 it is 0, 1 to 2 it is 1, and 2 to 3 it is 2, it is like this, and this side is minus 1, minus 2, like that, it's okay, like this. I think you have got this one, okay. So now you can see that every integer it is changing. So it is constant, it will remain constant for all integers x. So 0 to 1 it will remain constant, 1 to 2 it will remain constant, 2 to 3 it will remain constant, like that. So why not this integration, this 0 to 4 absolute of x dx. Now we will consider this range 0 to 1, 1 to 2, 2 to 3 and 3 to 4. That's all, okay. Now we need to understand what is the value. So within 0 to 1 its value is 0, so it is 0 into dx, because its getting integer value is 1, 0, no. Any point if I could choose from 0 to 1, suppose for example 0.5, its greatest value is 0 only. It is 0 only. Okay. Similarly, from 1 to 2, any value, its greatest value is this lower one. This lower one will be considered as greatest integer value. So this is 1 into dx. Similarly, it is 2 into dx. It is 3 into dx. That's all. Okay. So first integral is 0 because it is 0. Second one, it is simply x within 1 to 2. Next one, 2 times. This is x within. So this is a limit. Okay. This is not a greatest integer. Be careful. This is 2 to 3, and this is 3. Again x. This is 3 to 4. Okay. So you can see that it's 2 minus 1 is 1. 2 into this 3 minus 2 is 1. Plus 3 into 4 minus 3 is also 1. Okay. So 1 plus 2 plus 3, that is equals to 6. What are you saying? At integral value of x, function is not defined. Can we break the considering those values as the limit of integration? Now, function should be defined. Obviously, function should be defined. If function is not defined, how can I calculate this? Okay. So some values should be there at certain points. So which you are talking about? The function is not defined? Because, do you have any question? Function value can change suddenly. That is fine. May not be continuous. Okay. If it is not continuous, that is not a problem, because area under the curve, that we can calculate piecewisely. At 1, 2, 3, at those points, function values are not perfectly defined. So this value discontinuity is there. But area we can easily calculate. Area does not depend on any particular point. At particular point, area is 0. So area is integral. Integration means area from one point to another point, and that area will. So at particular one point, a to a, so 1 to 1. If I integrate any function, it will become 0. Okay, but discontinuity could be there, but easily we can find out the area. So I will give you one example. Okay, now suppose if this is one function and suddenly it is dropping here, and this is another function. Okay, so this value is suppose at 2, and this is 4, and this value is 1, and this value is suppose 2. Okay, so clearly it shows that at 2 it is not continuous, suddenly it is changing. So this function f of x is changing from 2 to 1 suddenly, but area we can consider. So area of this one we can consider, and area of this one we can consider, and we can add these two together. I have no issues at all. It's not necessary that function should be continuous in all the points. Then only we will be able to find the area. So area piecewisely we can compute and we can add it. Is it clear? Okay, it's good. So can you extend the previous problem? Suppose if it is 0 to n, so 0 to 100, what is the value? Can you calculate the value? Zero to 100 greatest integer of x dx. Anybody? Can you try? Okay. Is it possible to solve? So what we will do? This integration we can consider in the range. So total 0 to 100 you have to consider. I will consider 0 to 1, then 1 to 2, then 2 to 3, like that, up to 99 to 100. Okay, I will break in this region. Then what I will do? I replace this greatest integer of x within this one. This is the lower limit. Okay, so this is 0 into dx, this is 1 into dx, this is 2 into dx, this is 99 into dx. Okay, I think you are getting the point. Okay, so first one is 0, second one is 1 into 1, because 2 minus 1 is only 1. Then next one will be 2 into 1, then 3 into 1, like that. Last area will be 99, and this is 100 minus 99 is 1 again. So it's simply 1 to 99, this addition. Its value will be 99 into 100 by 2. Okay, so I think it will be, how much it is? So this is 5000 minus 4950 probably. Am I correct? Is it clear? Okay, so we can now move ahead. Okay, so anything, so if it is n, so you can write that n into n minus 1 by 2 probably. Okay, so we can generalize 0 to n, it is dx, so it is n into n minus 1 by 2. That is the answer. Okay, now next problem. Can you solve this one? Can you solve this problem quickly? So if you are confused with respect to this x minus 1, it's better to replace this x minus 1 by another variable initially, because x minus 1, if I can consider equal to z, then dx will be equal to dz, that's fine. But x and z, so you can see x and z, when x equals to minus 2, that time the z is your minus 3, and when x equals to 2, it is 2 minus 1, it is 1. So this integral we can now replace by simply lower limit minus 3 upper limit 1, and this is mod the greatest integer of z into dz. Okay, this will be easy, comparatively easy to understand. It is not required. If you can handle these things with the same form x minus 1, it is absolutely fine. Otherwise you can go for that. Okay, now this thing you can understand. Okay, now its negative sign is given. So what I will do, I will break minus 3 to minus 2, minus 2 to minus 1, minus 1 to 0, then 0 to 1. Okay, now this we know that at 0 to 1 it is 0 dx. So this lower limit is minus 1, it is minus 1 into dx, it is minus 2 into dx, it is minus 3 into dx. That's all. Okay, so this value is minus 3, because if I put this thing minus 2 plus 3 is 1 again 1, this value will become minus 2, this value will become minus 1. It's simply minus 6. Am I correct? I am skipping some steps. So dx equal to x, integration of dx is x. Now you can put lower limit minus 3 to minus 2. So but if that gap will be minus 2 minus minus 3, means minus 2 plus 3 is 1. So minus 3 is outside multiplied, so it will become minus 3 only. It's clear? Is it okay? I think it's fine. Okay, so if you have any problem, please let me know. So can you solve this problem? So this is combination of these two. One is absolute function, other one is greatest integer function. So I think this problem easily you can handle, because already we have discussed all the things. Just I will give you the steps, show you the steps, how to proceed. So this one I can write as 0 to 2 absolute of 2x square minus 3x dx. This is one term, and I can consider another term separately, 0 to 2 greatest integer x minus half dx. Okay, now how to take care for the first one? First one we need to understand when it will be 0. Okay, then sign convention you can go for. So when it will be 0, so this 2x square minus 3x, that I can write x into 2x minus 3. So I have one point is 0 at 0, other point 0 as x equal to 3 by 2. So it is more than 3, it is positive. Within this one it is negative, then again less than 0 it is positive. Okay, meaning is that 0 to 3 by 2 it should be negative, and beyond 3 by 2 it is positive, right? So we should break in two ways. So it is 0 to 3 by 2, and that time is negative. I should replace multiply minus sign, minus 2x square minus 3x dx, and this one would be then 3 by 2 to 2, next one is 2, it was there, that only I will consider, not up to infinity. Okay, that is positive, so I replace by same thing, I remove the mod operator, dx, right? So now this integration you can do, that is very simple. So 2x square, its integration is 2x cube by 3, it is 3x square by 2, okay? That you can do, you can replace this lower limit, upper limit. Here also you can replace lower limit and upper limit. But what about this one, next one, greatest integer function? Now when it will become 0? So thing is that this x minus 2, I will take different color. This x minus, not 2, this one half, that I will consider some integer k. K is one integer. Okay. Now I want to understand at what point, suppose I want to make k equal to 0. I want to get few points k and x. So k will be 0 when x equals to half, right? And k equal to 1 if it is, so k will be 1 if x equals to 1 plus half, means 3 by 2, right? Similarly 2, it will be 2 plus half, means 5 by 2, right? And k will be minus 1, I can put also minus 1, so minus 1 plus half means minus half, okay? So that is not given, so it is x equal to 0 to, so you can understand that when x equals to 0, then it is negative, so negative to 0, so that range I can consider it is minus 1, okay? So I think you are getting my point. K equal to minus 1 I can get, I have no space here, so k equal to minus 1, that time what is the x? X equals to minus 1 plus half, that means minus half. So what is the meaning? Meaning is that I will get integer k starting from k equal to minus 1 when x equal to minus half. So x equal to minus half to plus half, k will vary from minus 1 to 0. So this lowest, this greatest integer is minus 1. So if I consider the region, two regions I will consider, I hope you can sense this one. It is 0 to, I can consider half, up to half. Then I can consider half to 3 by 2. And another region 3 by 2 to the ultimate one 2. Okay, be careful here. When this is the change, when x equals to half to 3 by 2, that k is changing from 0 to 1. Okay, so that time it will be 0, it is 0 dx. Then it is 1 to 2 means 1 into dx. Clear? And this will be, here it will be minus 1 into dx. Is it okay? Are you getting this idea? How it is coming? So this breaking is important, otherwise what you can do, x minus half equals to z, that you can put and then just change the limit, and that will be much easier for you. Okay, so can you solve this problem then? So it appeared in 2022. So if you solve everything and you will get that, so this value, what is becoming, this total thing will become 0, you can check. So these two will contribute and this result will be, I think 19 by 12, that is the answer. If you solve everything, if you put the lower limit, upper limit, everything correctly, you will get 19 by 12. It little bit complicated. Complicated means calculation wise it is complicated, but idea is this thing only. you can break in this in that way. Okay, now let me go to the next problem. Again the similar thing, I'll give you the idea how to solve it, and then you can solve this problem. So now you see within the greatest integer function, now it is given minus 8x square plus 6x minus 1, right? So how to define the range? That is the main critical part. Otherwise it is very simple. Okay. So how to choose these things? What are the greatest values? Everything. Okay. Let me start here. So if I consider one function f of x is minus 8 x square plus 6x minus 1. Can you draw this function? Okay, so this thing minus I can take common, and this is 8x square minus 6s plus 1. Is it okay? And this one we can have factors. This is 4x minus 1. Okay, and I think 2x minus 1. You will get these two factors. Okay, so when this function is having zeros, and what is this plot? So that is a little bit tricky, you need to understand. Okay, this is your x, this is your f of x, and you can see that this function will vanish, will become 0 when x equals to, this one is x equals to half, this one is x equals to 1/4. No, so I can have these 2 points, this is 1/4 and this is half, suppose, and this is 1. Okay, so this 1/4 and this is your half, and this is 1, correct? Now here it will be 0, these 2 points it will be 0, and you can understand that if x is negative, x is very high positive, then it is becoming negative in minus infinity, and if it is minus infinity, then also minus infinity. Okay, so I can have this kind of parabola. This is a parabola. Now can you find out, you can find out the maximum value. What is the maximum? That you need to find out. So what is this maximum value? If maximum value is more than 1, I need to take care. And if just I need to understand whether it is more than 1 or not. So what is the value? Now can you find out what is the value here? Means at 0, f of 0. So f of 0 is obviously minus 1. No? If I put x equal to 0, so this value is 0, this value is 0, so this is minus 1. Correct? And x equals to 1, what is the value? So f of 0, I have got minus 1, and what is f of 1? If I put f of 1, x equals to 1, this is 4 minus 1 is 3, this is 2 minus 1 is 1, so 3 into 1 is 3, so it is minus 3. Okay, so at f of x equal to 1, f of 1 is minus 3. So now you see the problem here, and how to find the maximum value? You will take derivative of this one df dx, that you will put it 0, Okay, at that point you will get the maximum one. Okay, so first df dx, so this is critical problem, difficult problem. First df dx equals to 0, solve for that one. So can you solve it? I think so. One part is constant, so if I consider 4x minus 1 and this derivative is 2x, means 2 plus this 2x minus 1 is constant, is 4x, derivative is 4, and that I'll make it 0, right? So this is, to 2 I can divide is 4 and 2 4 8x, that imply it's a 8x. This is minus 1 minus 2 minus 3, it is 3, so it's implied x equals to 3 by 8. At x equals to 3 by 8, this one you will have maximum, and put the value 3 by 8 here. So x is 3 by 8, 3 by 8 here. So how much you are getting? So I think you will get less than 1. So f of 3 by 8 is less than 1 and more than 0. That you can check. Okay. So now range we are getting within this interval, no? This minus 1 to minus 3, because this is minus 1 and this will cross 0, and then it will be something positive but less than 1, and this side it is minus 3 height. So somewhere you will get minus 2. So where you will get minus 2, that also you need to understand. Okay, and where you will get again minus 1, that also it is required. It's minus 1. Okay, so minus 1 I have got 1 point at 0, one more point I will get here, and I will get one more point when it value will be minus 2, right? So can you draw these things, then you can define the range. So range is very, this problem is very critical, very critical. So if you can solve this problem, I hope you will be able to solve any other problem. Okay, so can I collect these things only? Okay, now let me redraw this one. This total figure I will redraw it. So you can see this is the function, and this one. Okay, now what I can do, I can redraw the figure in a proper way. This is your x, and I have 3 points, 1/4, this is half, and this is 1. Okay, and I have one parabola like this. This value is minus 1. So at minus 1, somewhere here I will get minus 2, and this value I have got minus 3. So minus 1, minus 2, and minus 3. So I need to get these few points, these corresponding points. So solve for this one. So put f of x equals to minus 1. What is the x value? Okay, that you can do easily. Okay, so this is minus a is x square minus plus 6x minus 1 equals to minus 1. This cancel out. So I think 8x square equal to 6x, x cancel out. So x equals to 6 by 8, means 3 by 4. So this is your 3 by 4. Okay, similarly this point you need to find out. Can you find out the next point when f of x equals to minus 2? I need f of x equals to minus 2. What is solutions? So what you will do? Minus 8x square plus 6x minus 1 equals to minus 2. Or you can consider 8x square minus 6x, and this is your minus 1 equals to 0. What is the x? X equals to plus 6 plus minus square root b square 36 minus 4ac, 4 into 8 into 4 32, so plus 32 by 2a, 2 into 8 16. Okay, this is very simple thing. So if you solve this one, so you will get a complicated term, and that term we are getting. So this is your, I think, 68. So 4 into 17, 217, 2 is cancelled out. So root 17 plus minus. So I will not consider minus sign because only one consider, I need to consider positive only. Root 17 plus 3 by 8. This is the x. So this value is root 17 plus 3 by 8. Got the point? So now we have got all the points. So now how to formulate this one? This is really difficult problem. Please take care. Now this integration, even this integration, I can remove this one. Okay. So I can break. What is the region? I can consider it is 0. So 0, next one is 1/4 to half. Next this one, then plus next section is half to 3/4. Next one is 3/4 to square root 17 plus 3 by 8 plus that one square root 17 plus 3 by 8 to ultimately 1. Okay, it's really difficult, but this problem came in 2022, so you can't ignore. You may have some difficulty to solve this problem, but it is very difficult. If you use this approach, then only you can do it. Now can you tell me this one? So at 0, what is the value? It's minus 1. So minus 1, so this magnitude will vary from minus 1 to 0 within minus this range 0 to 1/4. So this function value is changing from minus 1 to 0. Okay, some negative, so it is minus 1. Okay, be careful. Minus 1 times dx. Okay, now 1/4 to this one, this is less than 1. So 0 to 1, it is within 0 to 1. So it is 0 to 0 into dx. Then half to 3/4, its value will be again 0 to minus 1. So it is minus 1 dx. Then within this one, 3/4 to this one, its range is minus 1 to minus 2. So otherwise minus 2 to minus 1, that why I will consider. So greatest integer is minus 2. So it is minus 2 times dx. Then last one, this is minus 3 to minus 2. So minus 3 into dx. Okay. So this will vanish. This is 0. That one we can easily calculate, minus sign 1/4. Okay. Now we can easily calculate this value. So I'll calculate so that you will get confidence. So what is the value here? So this is minus sign 1/4. Okay, this is 0, it is also fine. And this one is -1 multiplication, 3/4 minus half. This is -2 multiplication, root 17 plus 3/8 minus 3/4. This is -3 times 1 minus square root 17 plus 3/8. Okay, so if you simplify, you will get the result square root 17 minus 13/8. Okay, is it clear? I think it is clear to all of you. Okay, now can I solve the next problem? So quickly I will go through these things. So this one I can rewrite this way, -1/2 to +1/2, and this is your greatest integer of x. This is -1/2 to +1/2 log 1 plus x 1 minus x dx. Okay, now how to solve this problem? So next term, second term is absolutely 0. Why? It is an odd function, and we understand that minus a to a f of x dx equals to 0 if fx is odd. Odd function means f of minus x equals to minus f of x. That you can do, because if I replace x by minus x, I will get log of 1 minus x upon 1 plus x, and log of a by b, I can write minus sign log of b by a, right? Thus it is negative, so this value will vanish, second term will vanish, it will become 0. And now this one, just how you can break these three regions. One is -1/2 to 0, then 0 to 2 only, half. Okay, so within negative sign it is a -1 into dx, with positive one it is 0 into dx. Okay, be careful this thing. So it is x minus 0 minus -1/2 plus 1/2, and this is absolutely 0, so the value is -1/2. Right? So this kind of problem we can solve it. The greatest integer functions we can solve it, and I have more problems. At least this one I want to solve it. Can you solve this problem? Okay, I think this is already more than 1 hour, all those things, 1.5 hours. So I need to stop here. But if you can solve this problem, please write in comment section. Okay, what is the answer? Okay, so there are several other problems I need to discuss, but I will make another video to solve those problems. So this one, can you solve it? This one, this is IIT advanced problem. It's a really difficult problem. Okay, can you solve this problem? This is 2016 problem. It appeared. Can you solve this one? Then this one is very easy problem, but nice problem. Can you solve this? This or this? this one, and this is final one. It's the advanced problem. Okay, if you can solve these kind of problems, please let me know in the comment section. And if you face any difficulty, write me there in the comment section. I'll solve for you. I'll make separate videos for each problems. I think it is fine for today. If required, please ask me to solve this problem in comment section. I'll be solving it. Okay, I'll give you the complete idea. Thanks for watching.